12-month.
And get picked up by a big tech company.
What Mike has built and what this team brings is it's AAA class.
And I thought, this is the model that we're going to grow Genus.
I would first look to contract out to Creating Coding Careers, where you're going to get experienced technology. The pipeline into your company for long-term growth.
So you're better off starting where you can groom and mentor and shape, people for your organization.
I've worked with coding teams for many years, and this was the first one that just picked up where we were and started continuing like they built it.
We're happy to have them in the building and see what they're developing. This is the second location. They started out with us in our building in Escondido.
Creating Coding Careers has this incredible combination of subject matter expertise in the technology field and what is actually required to do the job, as well as this network of employer partners who believe in the mission on changing what technologists
All right, we are live. Good afternoon, everyone. I am your host for today. My name is Alex Martinez from Creating Coding Careers, where our mission is to empower aspiring developers to seamlessly transition into dynamic realms of ServiceNow and software engineering. So get ready to dive into the world of data wizardry, because our guest today is none other than a bona fide data guru. Hailing as a Microsoft MVP, he's a maestro when it comes to crafting cutting-edge data pipelines, molding data lakes, and shaping data warehouses into perfection. But that's not all. He's not just about bytes and bits. He's been a true champion of ours here at Creating Coding Careers, generously sharing his precious time with our apprentices and esteemed alumni as a mentor. Let's drop some hearts for our next guest speaker, Mr. Dustin Benoit. Welcome, Dustin, and thank you for joining us.
Quite the intro. Thank you, Alex.
Yeah, man. So thank you so much for mentoring some of our apprentices, some of our alumni now. When I reached out, I was looking for people to talk about the Azure data platform, and you seem to just, pop up all over the place. I was looking for every single MVP on the Microsoft, platform, and you were always connected with each and one. I was like, I got to connect with this guy. And this is back when I was trying to look for mentors. And so this guy is very well known in Microsoft. So he's quite the guru. And I needed someone to talk about Azure and, the data side of things. And you were agreeable. You're more than happy to jump in and share your knowledge with us. So thank you so much. And I believe you have a PowerPoint presentation you're going to be sharing with us. So without further ado, I'm going to go ahead and bring in your PowerPoint presentation and hand it over to you. Looks like we're good to go. I can see it up here on my screen. And I'm going to hand it over to you to share with us the world of Azure.
Perfect. And feel free to, jump in with questions or things you want me to spend a little extra time on as we go.
Appreciate it.
So very kind intro. Really love what your organization's been doing here in San Diego area, and I believe beyond, but I'm local to San Diego, so I see Mike Roberts and you and others pop up a lot. So what I'd like, I know that we talked, or you all had someone recently talking about Azure platform, probably a bit more from a developer perspective, certainly not as focused on the data capabilities as I will today. So we won't go too broad for all of Azure, but there's a ton of data stuff. So bear with me. My plan is to do an overview of a lot of the important things and probably leave you going, that one sounds interesting. I should go dig a little more. And so because of that, there's actually tons of good YouTube videos. There's really good Microsoft Learn content, training content I can point you to. So I'll have that at the end, and happy to follow up to LinkedIn messages and things if you have trouble finding these resources to dig deeper after this session. So quick intro so you know who the heck I am. My current role is a field data engineer at Databricks. So I get to do data engineering type things, but really it's helping customers and prospective customers figure out the best way to use Databricks for what they're trying to do. And so with that, I'll call out that the thoughts and opinions about Azure and the data platform capabilities, these are kind of my opinions formed over time working with Azure, separate from Databricks, but Databricks is a first-party service within Azure, and I'll talk about that when I get to that slide. Also, I only have one slide about Databricks, so please don't tell anyone at my company that I only spent one slide on Databricks, which usually we talk for hours and hours about at the day job. All right, so I'm a co-founder of Data Engineering San Diego. Ike Ellis is the other leader now. Andrew Karcher helped co-found that many years ago now. So if you are in the area, come out to one of our monthly meetups. The next one's Thursday, the 24th, I believe. Yeah, Thursday, the 24th. We meet in person, and I do a live stream whenever possible. You can find my website and my LinkedIn info if you want to look for more resources and follow up with me later. And then, of course, there's technologies I like to talk about, but you're going to hear about the Azure side of it. So let's just kind of keep going with that. So I called out that I'm a data engineer, which means I work in like the data science and analytics space a lot. So I don't do as much with application databases, but I think some of the audience is probably going to really maybe find themselves using this piece and nothing else. And so when we talk about Microsoft Azure is a cloud platform. So if you're on AWS and you've never worked with Azure, it'd be very similar types of capabilities and ways of using it, where you have offerings that are super easy to use and kind of ready to go, usually called SaaS. Things that take a little bit more configuration, but will take a lot of the heavy lifting with operating systems and virtual machines out of the picture. Those are called platform as a service, or PaaS. And then there's infrastructure as a service, which is like virtual machines where I'm going and doing all of the installation and the management. So that'll come up a little bit in this databases section, and I might reference it a few times throughout. So if I'm working in Azure, I need a database to write data to, which often when we're building applications and we need to save data, we are working with some type of database. Let's start with kind of the relational database aspect of it. Probably the most common to talk about, one of the more popular ones, is Azure SQL Database, which is a managed SQL server. If you've worked with MySQL, Postgres, quite a few others, but if you worked with MySQL or Postgres, SQL Server is another flavor of SQL database. They all have their trade-offs and their pros and cons, but you can run that very easily within Azure just by spinning up an Azure SQL database. It's tied to this like logical server, but you don't really have to manage the server. You just have to pick your options and go. Because it's in the cloud, that means it's pretty scalable to on-demand. Either you can even do a serverless offering that spins up when you start to connect to it and then keeps running and then turns off when you stop using it. More likely for like a real production application, you're using either business critical, which is a bit more fast performance and really something you can rely on for production, or general purpose, which is a little bit less cost, a little bit less of the production performance and guarantees. I'll leave all that options for you to dig into later, and I'm sure you can find plenty of good YouTube videos about all your choices just within this one piece of the Azure data platform. But really, if I have tables of data, I have a user table of data I need to store, I have a bunch of events that are collected as they do things on my website, I might be writing that to two different tables in an Azure SQL database. And then I can use SQL, structured query language, to write queries, join tables together as needed, and do the types of things you would expect out of a relational database. Another way of using this that's a little bit, it's not really in the it's a little bit more on the PaaS offering side, and you have quite a bit more control of what's going on, is the Azure SQL DB managed instance. So for now, I think the thing I want you to know is that if you're working for an organization that might be moving from an on-premises SQL Server instance to the cloud, sometimes they find that they're using these features that I listed on this slide, for those that know what's up, the SQL agent job, some of these capabilities that aren't part of that SQL database offering, you would go to a managed instance, so you could keep using these features, and eventually you may try and move more towards the really more cloud-oriented versions of managed SQL database, or Azure SQL database, I should say, rather than managed instance. Now, the other really cool thing, though, is you can use Azure Arc to run these in your own data center, on Kubernetes, over on AWS. There's ways to deploy these types of managed instances in other places and still have them connect back to your Azure environment. Very much more advanced stuff, but just know that those capabilities are out there when the sort of simplicity and ease of use of the managed SQL database isn't cutting it for your needs. This is, I think, when I talk to analyst groups, they love to talk about this. I'll keep it short for today, but within Azure SQL DB, there's this tier called hyperscale, where you start to do very cloud-like things by separating all the storage layer of the database from the compute layer, and you can scale these things separately. So the idea is that I can save terabytes and terabytes or more of data in the storage layer, and at times I'm paying for a lot more heavy-duty compute on top of that. Other times I scale back down and I'm paying for much less compute on top of that. It just gives us the ability to scale to heights that you could not do with Azure SQL Database other tiers, and that you would be very hard to do with SQL Server on your own. And so it's optimized for transactional things. So optimized for things that your applications are going to do. If you think about processing any sort of like really important financial transactions, things like that, you really need to make sure that you don't have anything go wrong as you're reading and writing data. It's really meant for those kinds of workloads, but it also supports more analytic workloads really well. And in a moment, I'm going to tell you more about analytic workloads and some of the terms I use more on the data engineering side. In addition, just know that within the SQL database family, or Azure database family, we've got PostgreSQL, MySQL, MariaDB as options. I think this is all of them, but I won't be surprised if you find something else out there that did not make it on my slides. There's certainly other variations of that Azure SQL database that I haven't called out specifically. So those are all some options related to relational databases, which can be used for analytics, but often are used for applications and transactional systems. Now, a very popular way to do application development that's not relational is either using NoSQL or some other flavor of this non-relational database. And so Cosmos DB is a database system that supports actually quite a few ways of working with data. So you can stand up one that looks a lot like a MongoDB, stand up one that looks a lot like Cassandra. The data is going to be stored separately for these different flavors of Cosmos DB you can work with. But the idea is that if I've got to track a lot of user signups and sign-ins, I need to write a lot of data really quickly. I need to read back a lot of data really quickly. But I don't have a bunch of transactions where complicated stuff's happening. I actually just want to store a set of attributes for each user and always pull it back based on that username, or always pull it back based on one simple key. That's where Cosmos DB really shines, for scaling to high levels with very simple types of searches to pull back information that's going to drive your application. It also helps with graph. It does a lot of things. And so you can probably find people pitching Cosmos DB for all sorts of use cases. But that's kind of the basics of it, is when you need a NoSQL key value database, much like a DynamoDB over in AWS, that's where Cosmos fits in well. Okay, so that was more of the relational database, NoSQL database side. Azure storage, cloud storage in general, actually becomes super important in my field of analytics. I actually think it's important for all sorts of development these days. And so let me talk about a few different variations of that in Azure. So the thing that's been around for a super long time is Azure Blob Storage. And so that's basically the ability to store pretty much anything in the cloud on this storage that scales really well and gives you a good price, pretty low cost for how much you can store up there. And so there's some different options and things that are important there, but nothing that really is worth digging too deep into. What you do need to know is if I want to use this type of object storage within Azure, I would go and spin up what's called a storage account. When you spin up that storage account, I can choose to keep it as blob storage, or I can do something else called hierarchical namespace, which is the next thing I'll talk about. As I work with this though, we set up different containers. We can secure those containers individually if we need to. And then we just save a bunch of files. Blobs is what they're called. And all of these are just within containers within a storage account. The amazing thing about it though, is that as things have advanced, analytics tools and tools like data lakes will work with that cloud storage very effectively. And so there's this, when you enable hierarchical namespace on Azure, and this is pretty common, everything I do uses this, Data Lake Storage, Azure Data Lake Storage Gen 2, sometimes called ADLS. And so this is built on top of blob storage, but it works with all these big data APIs like Hadoop, like Spark, which I work with every day, those types of things. And it's more optimized for cloud analytics. So ADLS and blob storage are going to look very similar when you work with them, but they have some different attributes about how they work with tools and services. So those are two different flavors of cloud storage all within a storage account. This other thing that's super new, it's still in preview at Microsoft, is Microsoft OneLake. So they talk about it as one single data lake, but just know that this is the storage portion of your data. If I have tons of web views, if I have images that I need to go and do AI on and do some sort of recognition and processing of, I can put all that different types of data, the structured table data, the unstructured image and audio data, all into the storage system. I could do that with ADLS. With OneLake, you're going to have like a ready to go, easy to integrate offering that basically is ADLS without you having to set it up, choose nearly as much of the kind of networking and things like that. And so the idea is that each tenant, which is probably, if you think of like a Microsoft account, like a company may only have one tenant, they probably have just a couple, not very many. That would have one single OneLake. So we're putting all this data into one place backed by this Azure Data Lake storage that I just talked about. So when you hear OneLake, here's the important thing. If you're out there talking about Azure and you hear OneLake, it's storage that's meant to be used for analytics and your data lake processing. It's also preview, so you probably wouldn't be working on it at your day job. This is more likely what you'd work on like right now in a production environment. Okay, we are going to do Q&A at the end. So let's kind of keep going so I can kind of tell you what a data lake is after all this mention of data lake that I did in the first 10 minutes or so here. So when we talk about analytics on Azure, I'm going to talk a little bit about like machine learning and data science at the end, but let me start with kind of where I spend all my time. So I spend a lot of time on data lakes, though we actually have a new term, but data lakes is kind of the term that's been used for a while here. And a data lake is distributed storage. It's a cloud-based storage system or some type of really scalable storage system for big data. Usually the idea, if you put the data in this data lake storage, the storage piece of your data lake, is that we're going to do some analytics and some processing and probably these days some AI and ML, machine learning and artificial intelligence type processing on top of that data. So when I talk about data lake, which kind of conflicts a little bit with how OneLake's labeled in my opinion, but when I talk about data lakes, I talk about it's the storage piece that allows you to put a bunch of data in, store that data as it is, even if there's no schema tied to it, and then later you can process and evaluate it. So I can start collecting and saving data for the purpose of analytics without doing a lot of upfront work to make sense of that data. I'll do that as I process the data. The typical recommendation that we have is to put things into kind of our raw data zone where we might keep it around forever in case we ever need to reprocess, but then clean it up, enrich it, add more sort of quality constraints to the data and save it into like an enriched, sometimes we call the raw bronze, the enriched silver. And then finally have this like really clean, easy to use, ready for like reports that the CEO will look at to determine how well the company's meeting its goals. Put those types of things into the data lake as well, but more into like this certified, curated zone or container. And so a data lake isn't simply a bunch of data thrown together with no thought around it. And it's also something that beyond the distributed storage piece is something that's meant to be queried and used. And so your data lake would intentionally be set up with the idea that people can extract data out using analytic tools. And the analytic tools is actually a big part of this talk, which is why I paused to define a data lake here. So that's a data lake. It's something typically used for analytics and machine learning type scenarios, but it's built on cloud storage with other tools that work with it well. So if you've heard this term data warehouse, you might be wondering, okay, how's that different? So let's just talk about how it's different. That's the goal of this slide. So with the data warehouse, this data is already processed and modeled and ready for analytics use. So if someone's writing a bunch of JSON data every time let's say it's Netflix and I'm starting a show on Netflix, as that show goes on, it's tracking some kind of data in the back end. We'll pretend it's using JSON because that's a pretty common format for developers. Sending off these JSON messages every certain amount of seconds to say what I'm doing. It might track when I pause, when I play. That data, before I'd put it in a data warehouse, I would actually kind of parse through it, make sure all of that JSON data fits into columns that have been well defined, probably look for like empty fields and things like that and do some kind of replacement on them, get that stuff ready for reporting before I put it in a data warehouse. The data lake, I'd put it in the raw zone, do some processing, put it in silver, do some processing, put it in gold or certified. Okay, so back to data warehouse. It's structured data. It's also meant for interactive queries. So I want to be able to think of a question. What's the most popular show right this minute in San Diego? Run that query and get quick results back from my data warehouse system. Probably it's more like what's the most popular show this week or this month rather than this second or this minute if I'm talking about a data warehouse. They're usually a bit more historical looking. Finally, these are going to work really well with like dashboard tools. So if you've ever heard of Power BI, if you've heard of Tableau, if you build any reports in, D3 used to be what we used. I don't know if that's still what people use, but build them in like with JavaScript into a web browser. Those types of tools are really meant to be able to query a data warehouse pretty quickly on the fly and get the results back for users. Not always as fast a response as like a specific query with the right where clause, with the right filter against Cosmos DB or against a relational database, but meant to aggregate data quickly and bring back more analytical type aggregated results. So data lake, large storage, a bit more wild, a bit less processed. Data warehouse, ready for interactive queries, way more processed, often more expensive though, or at least more expensive for each table that you have in there. Okay, so let's talk about Azure Databricks. So I work for Databricks. Again, these are kind of my very quick take that I have slides and slides and slides I could have used instead. Databricks is multi-cloud. It works in AWS, Azure, Google Cloud. But the Azure Databricks offering is actually a first-party service. It's a partnership between Microsoft and Databricks. And so you can go into the Azure portal, as you're spinning up your cloud storage, as you're spinning up whatever else you need, maybe some virtual machines, you can spin up an Azure Databricks workspace there. And so with that, Databricks is really driven around, this is kind of their older slogan, but I think it still applies pretty well. Unified analytics platform. So not just a place for data engineers, not just a place for data scientists, a place for all sorts of analytics, including those types of data warehouse queries I just talked about. They have a different way of doing it than we traditionally did, years and years ago, but a new way of doing data warehousing that fits well in the cloud. It uses Apache Spark, which is an open source distributed framework for data processing. If you haven't heard of Apache Spark, that's fine. It's a very data-focused thing. But it's a really cool technology. On top of that, it has some performance optimizations that fit with the open source version of Apache Spark, including a whole separate engine called Photon, where you write Spark code and it runs it on this different engine that's works better for some use cases. Data engineers, data scientists, BI analysts, all of your reporting can all work within this platform and save the data to one gold table, one of those certified tables, reuse it in a bunch of different contexts for a bunch of different users, which probably would take way too long to describe why that's so important. But if you do data analytics and data science for a while, you'll start to see how problematic it is when everything's spread out across different tools and teams aren't able to easily work together and just send a link that says, hey, check out this table I built. It's got really useful information for what your team's doing today. And then Databricks, along with quite a few of the tools that we'll talk about with Azure, is highly scalable, but it's really good at scaling out elastically as you work with it. Now, Azure Synapse Analytics has a lot of similar sounding things to Azure Databricks, but this is actually built by Microsoft and is a part of Azure, where they brought together some different capabilities they had in the past for analytics, as well as added some new features. So Synapse Analytics, I'm thinking it's been 3+ years since it went generally available and became really usable. Maybe it's a little more or less than that, but somewhere around 3 to 4 years. It's this integrated analytics service bringing together a bunch of stuff. Apache Spark is still an option, but there's also a bunch of options around SQL querying that look a little bit more like you would use in the SQL Server space, because a lot of Azure customers have worked with Microsoft for development for a long time, and they're familiar with SQL Server, familiar with the specific Transact SQL language that SQL Server can support. So this supports that as well. In addition, they have this like drag and drop low code data pipelines capability to build out your jobs that load data to these data lakes or load data to these data warehouses. So to give you like actual names that you'd find in the UI, the serverless Apache Spark is the tool for running the types of distributed coding focused pipelines like we do a lot in Databricks, and I've done a lot in Synapse as well. Serverless SQL is a way to quickly spin up like this query engine to run against the files in your Azure Data Lake storage. So it's a really kind of spin up when you need it, pay for the amount of data you read is how that payment works, and get back fairly quick results off your data lake. For the more high performance use cases, like anything you'd build into an application that a customer is going to click on and expect a really quick result, they have something called dedicated SQL. That's a massive parallel processing database. It fits well with like big data warehouse tools, such as Teradata, such as Amazon AWS Redshift. It kind of competes with those things. And then finally, Synapse Pipelines is the name for the low-code data ingestion tool within Synapse. There are a few other pieces that are actually baked into Synapse that I'm not going to even talk about right now, as well as some things that integrate pretty well. So, my image got a little bit blurry as I copy and pasted over and over again. Sorry about that. But this Azure Data Factory is actually the same type of thing as Synapse Pipelines. They look very similar. They work very similar. And so Azure Data Factory is a way to drag and drop to build ETL. ETL being a job that extracts the data from one place, such as a SQL Server or Postgres database, do some sort of transformation and processing to it. That's what the T is. And then load it to another system, oftentimes Azure Data Lake Storage, sometimes to another database like an Azure SQL database. Now with it, you can run these serverless data pipelines, which is it's a nice feature that you can get serverless out of most capabilities these days, but it's something nice to know that this offers. It has scheduling and alerting, so sometimes we use it to schedule other jobs rather than to do the ETL itself. And then it can auto-scale in things to work with your data sizes. So I won't go crazy on this, but this is like a super simplified, but maybe still a little confusing, super simplified image of what might work together to ingest data to your data lake storage. So if I have data in source systems, it might be coming in from a web application real time into event hubs at the bottom. Event hubs is a place to collect a bunch of events or messages and as quickly as requested, send them along to the next step. So I'd send a bunch of, hey, Dustin just clicked pause on this money heist video on Netflix, send that message along to event hubs. Databricks is going to be very consistently asking for those messages, and I process it with something called structured streaming on Databricks. The other approach for something that's going to run once a day would be read all of that table or everything new in that SQL table on Azure SQL Database. I might do that with Data Factory. I might do that directly from Databricks, process this chunk of data and save it to ADLS, Azure Data Lake Storage. And then that double arrow between Databricks and ADLS is that I would save it to raw, like I talked about in the data lake slide, do some additional processing, clean it up a little bit, enrich it, save it back as a enriched table. That's just a little bit more useful for anyone that's going to be using this for analytics and data science models. Now, if I use Synapse tools instead, I'm basically just swapping out a few pieces of this for Synapse Pipelines for Azure Data Factory, which, like I said, it's pretty much a different name for the same types of capabilities. And then Synapse Spark for the Azure Databricks, a big piece of what the Azure Databricks box was doing. And while I could do some streaming with Synapse Spark, I'm more likely to look to like Stream Analytics to do streaming from event hubs to ADLS within this platform. Okay, so this is a lot. We haven't gone deep into these, but we've covered a lot of technology that has sort of evolved and come out over time with Microsoft. But there's a new one just to make it very interesting. In preview right now, you can actually, I'm pretty sure it's open to everyone. You can go sign up to get a trial of Microsoft Fabric. And Microsoft Fabric is essentially taking the types of capabilities I've talked about with Databricks, with Azure Synapse, and making them this new evolution of that. And so it's going to have data engineering capabilities within it. It's going to have data warehousing. It's going to support data science, data factory, and Power BI for like your reporting and analytics needs. I think real-time analytics might be listed separately, but that's kind of in the data engineering camp for me. So Microsoft Fabric it's preview right now. So don't run out and tell a company to do their production workloads on it quite yet. But it's got a lot of interesting capabilities and a lot of evolution of what we saw within Azure Synapse. So rather than try to cover the hours and hours and hours of videos and blogs about Azure Fabric that's been out for a little bit now, I'm going to point you to a couple of things. One, I'll talk through just a few pieces of this slide that I think are interesting, but mostly if you go to learn.microsoft.com/fabric, that's like the documentation. So there's more product focused pages. There's lots of YouTube videos, but this link here, I think is a good place to like start, just read through that first kind of overview piece of it and then start digging around to see what others say about it. So with all these capabilities, remember way back at the beginning of this, we talked about storage, or in the middle of this, we talked about storage. And I said OneLake. This OneLake storage is kind of in the center, bottom center of this whole platform. And then we've got different ways to work with Delta format data that's saved in OneLake. So we have a warehouse way of working with it, a lakehouse, CustoDB for different types of workloads, and then data sets for Power BI. I think that's probably as much as we need to spend on this for the moment, because there's so much to it. It's hard to kind of consolidate. So let me do a quick run through of the AI/ML side, and then we can do some Q&A to make sure we really get your questions answered. Okay, so AI is artificial intelligence. ML is machine learning. Memorize those if you're new to this space. Those are always abbreviated. So cognitive services is something that it's not as exciting these days as like large language models, LLM like GPT, but this is a really cool capability of Azure. It's a bunch of individual services. You're not going to just spin up cognitive services as a thing. You're going to go pick a text translation service or a speech service or an image recognition service that are all kind of within this Azure Cognitive Services family. And the idea is that without tuning them and customizing them at all, you can start making calls to this from your applications and have these AI capabilities actually give you feedback that you can use, such as look for famous people in this image, or give me kind of a text summary of what's in this image. Now, when you get to like text translation and different things related to text, probably a few other categories too, customization becomes important. And so some of these services support customizing it to fit your own use case. So cognitive service has been around a while. It's really a collection of things. It's really meant to be easy for developers to make use of these types of capabilities that take a lot of work to build yourself. Azure Machine Learning is a bit more on the I'm going to build it myself, my team's going to build it ourselves side of things. And so with Azure Machine Learning, you typically, like, this is a tool for data scientists. And there's a reason that word science is in there. Data scientists do experiments. They have this hypothesis or this idea, such as, I bet we could improve how many people click on our social media posts, let's say. It's probably a really lame example, but let's just go with it. So they do an experiment to see, like, if we were look at all these different factors and try to do this predicted action, will that make a difference? And they can evaluate that. And so recommendations is a really good one too, right? I talked about Netflix earlier. Recommend what Dustin wants to watch next if he just watched Money Heist. So you'd build these different models, track them through experiments. You'd have some sort of compute. Azure Databricks is one of them. Virtual machines is one of them. There's a few different flavors beyond that. That's going to run the pipelines and run the processing. And then pipelines is a way to like process the data through and actually get to the models themselves. So Azure Machine Learning has a lot built into it. I'm going to point you at the end to Kevin Fiesel has pretty recent stuff on YouTube about Azure Machine Learning. He probably also talks about the Fabric data science offering, which has a lot of these same things in it. Let's talk a bit about streaming. I'm going to skip slides. I knew I was going to skip these slides, so don't worry. So when I talked about Event Hubs earlier as a place for data to go, let me just kind of let you know, in case it comes up for you, what this is about. So if I have data coming in all the time, because I've got customers all over clicking buttons on their application, doing things with what I built, that data is going to need to flow in, and we don't want to just flow straight to another application or service that has to keep up with it all the time. We want a very stable, scalable broker, a place that I can send all these events and then stop worrying about them, decouple myself from the thing that's going to consume these events. So on the other side of Event Hubs, we have application systems that are consuming from Event Hubs, and Event Hubs is just the middle person in this whole thing. So technically, it's a scalable message broker, decouples producer and consumer. It's compatible with Apache Kafka APIs if you're familiar with that. Logically, though, this is the important thing. I have data streams coming in, my taxi trip data, my taxi vendor data. Those are both different hubs within Event Hubs. And then I have different consumers that might be reading, each of them reading from one of those hubs, or from both of those hubs, right? So as I send my trip data into Event Hubs, I stop worrying about it. This service is holding that data for a certain period of time, and then one or many consumers can read that data off. In addition, specifically within Azure, working really well with Event Hubs and a couple other source systems is Stream Analytics. It's a way to write SQL language to do streaming, working with a few of these Azure services as sources, and I think a larger number of Azure services as destinations. Not as broad of support as like using Spark structured streaming, but it is a pretty powerful way, and it can integrate to Power BI for real-time reporting, which is pretty cool capability. So somehow I did it. I got through those slides about as quick as I wanted to. I hope I didn't run talking too fast. Deal with the Q&A, but let me point out that there's lots of places to learn this stuff. This slide is literally only linked to Microsoft. I put Databricks in there too. Databricks.com/learn has a bunch of different links to the Databricks side of things. Microsoft learn.microsoft.com/training has all these paths that you can go down that are free and are meant to help you go from like, I know nothing about this to I have stood something up and tested it a little bit, and I can now talk about it as if I've used it. Probably not going to get you to an expert level unless you really go through a lot of learning paths on the subject, but very good way to get started. And then this slide here is a link to my stuff. You can probably just type most of it in, youtube.com/JustinZanoy. I've got stuff about Databricks, Spark, and really data engineering side of things. Down below on YouTube again, go to Advancing Analytics for a ton of stuff on Azure. Kevin Kiesel has his Azure ML stuff plus a bunch of other stuff. Ike Ellis is there on YouTube as well, and Free the Data Academy has much less of an Azure view, but more of kind of getting the skills for data science. So yeah, like you have to let me know how to get these links in if you can drop them in the chat here. But yeah, do we have any questions, any Q&A that we can do here?
We do have a question. This is from Anna Davis. She's one of our apprentices right now. I'm going to go and bring this. I don't know why the audio kind of just died down a little bit. Hopefully this helps. So our first question is coming from Anna Davis, and Anna is asking, so she wants to know which Azure tools are best for the DevOps space.
So assuming the question is about I need to do DevOps within Azure for deploying Azure resources, they have, oddly enough, their tool to kind of orchestrate all that is called Azure DevOps. So there's an Azure DevOps like service workspace that you can get into. And so if you're familiar with like Git repos, version control type repositories, you can save a repo that works a lot like a GitHub repo would, but do it on Azure DevOps instead, and it's a little bit more integrated into some of their things. But Terraform supports Azure very well. So Terraform's multi-cloud and very useful for DevOps professionals across the across cloud systems and other places. Then Azure Resource Manager, the ARM capabilities and like ARM templates that you can export once you build it in the UI are a very powerful way to do DevOps as well. So setting it up and coordinating it all with Azure DevOps like service, and then using either ARM or Terraform to deploy like resources and things like that. And then for code deployments, you kind of get into the typical options you would have for deploying code, depending on where you're going. It changes up a little bit. Hopefully that's helpful. Feel free to ask a follow-up if I completely missed it on that one.
Yeah, feel free to have any follow-up questions. Anybody who's out there, please go ahead and start dropping your questions. And now I have a few of my own. Let's see. So I always like hearing everyone's origin story. I always want to hear how you guys got involved in tech. I'm looking at your LinkedIn here. It looks like you've been in tech, well, since the very beginning. You graduated with a degree in computer science and worked your way up the ranks. When I think of data, I always think of maybe the first job you get is kind of like a data analyst. You mentioned tools like Tableau. Maybe you're getting, you have these data that's already been sanitized, and you're trying to present it, like you said, for like executives to kind of like analyze what's going on in their business. And then you graduate into using that data to maybe even predict like what's going to happen in the future, kind of like data engineering, data science. I'm curious, could you share with us your origin story, how you got started out and how you moved up the ranks?
Yeah, so I started somewhat traditional in that I didn't start, maybe traditional is like I was 12 years old and I picked up a magazine and started coding. There's people like that and they're usually brilliant. That wasn't me. I did instant messenger and stupid stuff on a computer. And then it came time to like write papers in high school about what am I going to do for a living? What if I go to college, what's my major going to be? So I got some really good advice from my dad going, these computers, that's a pretty good field to get into. And so that's really, I think, helped steer me that way. And it was kind of tough to jump into it. Most of my learning happened initially in college. And so I felt a little bit behind as I went through. One of the links I had, and it's probably not too hard to find if you just go to dustinbanner.com. I did write this journey down because it comes up from time to time if you want to read more about it. But basically what happened is I went through a computer science. I did good at some things, not so good at others. And I got to interview for this company, and they're hiring BI people, business intelligence, which is very much in the data space, or application developers. And so they interviewed me for both, and they only offered me one job, which was business intelligence. And I was like, okay, so apparently I'm better at that than I am at application development. And so for a variety of reasons, that sounded like an exciting opportunity. And so I was actually a BI consultant straight out of college, jumped in, learned a lot on the fly. Very much like you said, on the data analyst side of things, though, for me, it was a lot of like learn the specific platform and be able to go and help people set it up, teach people how to use it, that kind of thing. And so along with that, I learned some different technologies, found a way to basically just use what I knew about one of those technologies I liked to get a different job. And then at that job is where I started having to go learn a bunch of stuff on my own in my free time that no one was telling me to learn. Because I saw that either the company I was at or the next place I go needed to work with the cloud, needed to work with these big data systems. And so I started to learn that stuff completely on the side, basically. Thankfully, I got some opportunities through my work. So, I was fortunate there. But yeah, that's where it kind of turned to, got a good baseline, but I still got to keep, and I'm still learning this week, today, right? Like Fabric came out several months back, and it was a scramble to go, what is this? How do I use it? What's it going to be in 6 months, even though, it's a preview version. So that's one thing to know if you get into data, is that you're going to have to keep learning and evolving to new things. It's probably true of all development going forward, but for sure it's been the case for data jobs.
Answer appreciated. So I've got another question. So as you know, we have a lot of people that are barely dipping their toes into tech. We have people transitioning for other industries, and so they're barely getting introduced to tech. This is a great question coming from Clinton Paris. Clinton asks, what language would you start with for a beginner in software development?
I would start with Python. That's my simple answer.
That's a data science answer right there for sure, man.
Yeah.
Says, yeah.
I would start with Python. JavaScript is super popular. There's so many flavors and versions. I don't know where to go with it, but JavaScript and Python are used a lot of places. And I think Python's easier to get started with. Once you get past the indentation stuff, which is actually a good practice, once you get past that, I think Python, you can just import libraries and go. You don't have to build nearly as many data structures and capabilities yourself to build a cool application. And so it's kind of like learning a language. If you're not like using it to do something, it's kind of boring. But once you start like using it to actually build something, even if it's just a silly side project, I think it becomes more exciting.
And Python over R. So at one point I was kind of interested in, I think R was popular as well. Is that no longer the case?
I will not formally say anything about whether R is, it's still heavily used and out there, and there's still jobs for R for sure. I'm a data engineer, right? So I'm more I'm more in the back end, and so Python gets you a lot further as a data engineer. If you're truly doing data science and models and things, I'll let other people argue about which one's better, which one has more jobs. I don't think I'm the right person to get into that debate.
Appreciate it. So we have another question. This is also coming from Anna, our apprentice. What best data strategy would be good for my mobile apps and connected cloud native site called BAM, which is a product, service, viral promotions project that allows many influencers and people to post a multi-connected social media ecosystem? Two other projects of mine, Track a Perp, Bully Bigot, viral reporting, mobile apps, and sites. We'll need to utilize the same big data layout as well. Would Azure Blobs or Data Lakes be good? I know the data containers would need to be highly elastic.
So if you're tracking the data, so I'm not going to be able to give I wouldn't run too hard with this answer, but I'll give you some things to think about here. If you're tracking separate parts of data that you're going to need to relate to each other and basically join together when it comes time to make sense out of them and have reporting be useful, using something like a relational database, Azure SQL DB, MySQL, Postgres, like that's usually a good starting point if you expect to store a bunch of stuff separately but have some relationships and tying together. If you expect to have a lot of data and do some really complex analytics on top of it, that's where you might go the data lake approach. So it's probably cost effective to save it as Azure storage, but the processing out of Azure storage may not be as simple and cost effective as doing it just in a relational database.
Got another question here for you. What's a typical day look like for a data engineer?
Yeah, that's a really good question. So often there's a decent amount of sitting and like programming in some way. Now for a data engineer, you're probably not handed a piece of paper, not a piece of paper, right? You're probably not sent an email that says, I need you to build this. Here are the requirements. Let me know when you're done, right? I don't know if anyone's given that anymore, but it used to be said that that's how it worked. It's never been that way for data engineers. We're trying to run this report to determine how many customers are churning, how many people are leaving as customers to go to the competitor. And we're missing these 3 fields and this other field we don't trust. It looks wrong. Can you fix this, right? And so it's a lot of talking to business professionals, people that domain experts may be a good way to say it. That's kind of across everything. Domain experts that really know what's going on for the company in the real world. They probably know how it gets put into whatever system they use, like a Salesforce. On the IT side, it'd be like a ServiceNow where they're tracking all this stuff. And they need someone to take it out of that system, do a bunch of cleanup and joining to other systems data to make it happen. And so you're trying to understand where does this data come from in the first place? Is this all of the data or is this just a portion of it that you're aware of? And how do we do this in a way that someone else can use it? So there's a lot of decision making that happens, even though the request is, can you give me these 3 columns into the analytics database or the data warehouse so that we can add it to this report? That often as a data engineer, someone else is building the report. Often someone else is building the machine learning models. And you're sort of this sometimes appreciated, sometimes not appreciated expert that has to figure out how to give them all the things they need, including sometimes the tooling to make that available. So, if I spend half a day coding, that's kind of a lot. If I spend half a day in meetings talking about requirements, that's kind of a lot too. But I expect to do both of those each day, as well as like maintenance and stand-ups and that kind of thing. So we always value data engineers that could interpret from a data perspective, what do I need to check for? What do I need to do to serve this need? Not just, we need these 2 fields. They get it done without any questions or, validation that this data even makes sense for the goal in the first place. Hopefully that's helpful.
It is. It looks like at one point, being quite the expert that you are, you kind of broke out on your own and did a little bit of consulting work. Do you have any interesting client stories, like nightmare stories or fantastic stories that you'd like to share?
Probably not, but I'll share something that's probably not exciting, but is I think interesting. It actually started when I was sort of the first data engineer on a team as a full-time employee. But that DevOps question, like I ended up doing a lot of DevOps type work for different periods of time, and the reason is that they'll bring in a data team for a very specific reason, especially as a consultant, I guess. But the other people that typically support software developers, including the software developers themselves, may not really know data. It's changing, right? It's more prominent now. And so they say, yeah, what do you need to use? And I'm like, oh, I need to spin up Azure Synapse, and I need to set up these private links between these different services so I can move this data. And so there's requirements that this has to be scripted. We have to use infrastructure as code. We need to deploy it in an automated fashion. We need automated tests. And so you end up doing a lot of things that are completely outside of your expertise in order to be able to deliver the thing that you probably have the skills to build already. And so I think that's as much detail as I'm going to get into. So I did get to modify 20-year-old code to write it in Python instead of Bash and the other components, but that wasn't really that's not a lot of fun in that story. It was just a grinding experience.
We got another questions just coming up from Anna as well. So we got a quick fire question. What is your favorite hobby?
I love to do things with my family, like go for walks or hikes or the beach, even though it's challenging. I also spend a decent amount of time trying to practice Spanish and get better. We're trying to form a bilingual family here. So, like going down to Mexico and things to push ourselves a bit.
Yeah, a ver, dime algo en español.
¿Sí?
You have this co-organizer. You're the co-organizer of this group in San Diego, and I want to make sure everyone's welcome. Is it okay for everyone to kind of like, pop in on you on Thursday? It sounds like you guys have events every month or so, and it looks like one's coming up on
typically
Thursday.
Once a month. Yeah. So if you're interested in data engineering, we typically have a topic you can kind of look at, and you can always go look up the terms in advance if it's not your specialty. But if you're interested in the data engineering side, yeah, RSVP to come in person or RSVP and you'll get the live stream link. And we do our best to capture the audio. There is a lot of group conversation. There is a decent amount of like people just trying to network and catch up with each other ahead of time. So we have plenty of people that aren't data engineers yet and
Perfect.
Have a little bit of interest in it that join, and we love it.
So it sounds like it's beginner friendly. Definitely might pop in on you.
The topics may go really deep. I'm not like, we don't necessarily keep those to intro level, but you're welcome to come and do what I do, which is look up all these things as they're saying it. They throw out a new data engineering term, like everyone in the world's using it, and I've never heard of the thing, and I have to quickly search it and see how popular it really is.
So I know we're coming up on an hour already, and I appreciate all the time you're spending with us. I just want to ask any last advice you'd give for anybody who's just starting off in their tech career. What kind of bits of advice can you give us?
Yeah, so my number one advice, it actually is true of all careers, but it's honestly what helped me get the opportunity to learn and jump into different things, in my opinion. My number one advice is to like be a good teammate and like not just show up on time and stuff, but like be helpful. Be willing to dig into stuff, and like people know they can count on you to put in the effort and try and help them out. And I think what happens when you do that is that they go to another company or jump to another team. Your team either stalls out or they let you go because things go up and down in this industry. And then someone else is willing to hire you to go write Python code, even though you haven't actually done that in production yet. You've just been learning it through YouTube or learning it through Coursera or whatever. Like those kind of things happen when people want you on their team. So that's my number one advice. And always be learning is number two advice. Like keep learning. Don't settle in and think you've got it, because unless you're in the last few years of your career, I just don't think it's going to pan out that way where you don't have to keep learning new things.
Yes, I wonder if you would also agree that networking is probably up there as well, as far as, getting to know people in the industry, and that kind of helps you move along in your career. I see that you've been working with some great companies. You got Intuit up there, you got Databricks up there. Curious how you kind of climbed to the top. Were those through networking events or networking with people in the industry? How did that work?
Networking's really good. I've learned a lot by doing meetups, attending meetups, speaking at local events where everyone's accepted. Like, I've met people that way, and it's been really good. I've also just, of all the applications, made it into a company somehow through the normal application process. I know it's hard, but sometimes it happens. And then from there, those relationships led to other opportunities.
Dustin, I really appreciate you spending your Friday with us. Thank you for that great presentation that you put together. If anybody wants to connect with Dustin, I'm going to drop his LinkedIn, if that's okay with you, Justin. So go check out his LinkedIn profile. You're going to find his YouTube videos, a lot of great YouTube videos for people just breaking into the industry. Go check out his website. I believe I dropped that in earlier. And any other resources that you'd like to drop?
So I got a ton of them. What's the best way? Should I go find this and throw them in the comments?
I think the best way to do it would be to send them over to me, and we're going to post about this on Monday. And awesome. I'll go ahead and put all the resources that you had on that last screen that you showed us, and I'll make sure those are all there for everybody to visit. Sound good?
Yep. Yeah, definitely. Don't forget learn.microsoft.com/train. Get you a lot of stuff. And then, I'll give you some to like some individuals that have taught me a lot along the way.
Absolutely. And I don't know if that that PowerPoint presentation would be available, but if it is, I would love to put that one up there. There's a lot of great information on there. So appreciate everybody for joining us on Friday. We'll be seeing you again next Friday at 3 o'clock, same channel, same time. Again, thank you so much, Dustin. Everybody have a great evening. Everybody have a great weekend and stay safe. I know we got a big storm going to be hitting us sometime soon, starting either tonight or tomorrow. So everybody stay safe. See everybody next weekend.
Yeah.
See you, Dustin.
Thank you.
Thanks again, Dustin.